This is the term project for CSI2372. I'll be explaining the code first. In our main function, we have input_words.txt, and we are reading everything from this file into a stream, a buffer stream, and then we're going through every word in this buffer and adding it to three separate sets of vectors, depending on if they have numbers or they are misspelled. We then go on to get the values of each letter from lettervalues.txt, and we calculate the values of the word based on those character values, and then we write them to output sorted words with values.txt. We use the calculate word value function here, and one of the things I've changed is that I've made this letter value map a reference so that we're not making a new copy every time. We then go on to count the number of occurrences for each word and sort them in a descending order and write them to output sorted numbers.txt. I then go on to erase every duplicate in the words vector, and I use multi-threading to process find most similar word for every mixed word in the mixed words list. I also pass in the modified words list vector. In the find most similar word method call, we are taking in the target that we're trying to reach and a word list which contains all the possible words that we want to try reaching from. We initialize our most similar word and we set a max for the min distance at the beginning. We then go through every word in the word list and we calculate the Levenstein distance with passing the target, the word, and the min distance. We then return the distance, and if the distance is less than the min that we currently have, then we would update the min and we would also change the most similar word accordingly. And if the distance is 0, then we know that we have reached the optimal case and we would return the most similar word. Regardless, when the for loop finishes, we would see which word is that is the most similar word, and that will be what we would return. In the Levenstein distance calculator function call, we take two strings and a integer representing the current minimum distance. We then initialize two vectors which are not 2D, they're just regular array vectors. And the reason that I've removed the 2D array is that you don't really need all of it, you just need the two rows that you're working with. So this is more efficient with regards to memory. We then go through every single element in the first row and we initialize it from values of 0 to length 2. And then we go through our main for loop, which will go through every single row and initialize the first element with the I value that we're currently in. We then go through the inner loop, which goes through every character in the second string and calculate the value, the minimum value of three possible operations, and it also takes into account the possibility that the characters that we're comparing are going to be the same. Next, we find the minimum value of the row that we're currently in after we're done with the inner row, and based on that minimum value, we compare it to the minimum distance. And if it's greater, that means that the Levenstein, we don't need to complete the rest of it because we know it's going to be obsolete because we already have like a better match. We then swap the previous row and the current row, and at the very end, if we have not exited early due to this exit condition, we just return the Levenstein distance value. I'll now showcase what an example of running the output looks like. We can run the output by using this command, and I print the corrected words and their mixed words into both onto the terminal and onto the output corrected mixed words.txt. Thank you very much.